Good morning, friends and neighbors. It's been a while. For a long time, I was doing 3 or 4 videos a day. A lot of shorts out there. Trying to make sense of it all. Something we all do. So, what's new? What's going on out there? Anyway, discords over pollution. What is pollution? That's just a huge conversation. So where I went is risks. What are risks? How do we measure risks? Risks aren't absolute things. They're relative. Although some risks are absolute. The risk of the sun exploding, which we theorize happening in the far future. It's kind of a risk. It's an absolute risk if it does happen, and we've seen it happen with other suns in other distant galaxies. So, amazing place. Anyway, what got me here? Well, the tritium dump that our nuclear experts working with Fukushima are doing. Tritium's interesting. If it's bound as water, tritium makes super heavy water. Not heavy water that you've maybe heard of from nuclear research and World War II articles, but super heavy water, which is tritiated water. Typically, this would be water, an H2O molecule, that the two hydrogens, or one of the two hydrogen, is a tritium atom. Tritium is a form of hydrogen in the isotope, or in the periodic table of elements. So what's interesting in that idea, that thought, that notion, that releasing this tritium has no risks, is wrong. It's a poor assumption, because we can go see the risks of tritium in what are called MSDS sheets, and those are sheets put together by industry and the government about the risks, potential risks of chemicals in our environment. So there's a piece of evidence tied to a piece of evidence tied to some sciences and some processes that are out there. So super heavy water. Why would that matter? If you understand separation sciences, how things precipitate, move through the environment, move through a fractioning column, these types of things that are science that go on, then there is a potential for that tritiated water to separate out and condense into specific layers in the oceans. This would be dependent upon currents, but the currents might help this separation process happening. This is heavy water. We now can identify snow that contains these properties and where it falls out because of separations done in the atmosphere. Molecular separations, huge thing. Anyway, so there's a risk. Not discussed is a risk and the actual potentials of the risk. This comes out to parts per million, parts per billion, parts per thousand, or parts per hundred of sick people, and maybe specific areas or locations that are exposed to this risk. This is what big data, big information about healthcare informs us about. Big things have to work. It's a globe. Get over it. Get past it. All conspiracies aside, business goes on. So, where did I come to? The conversations about the impact of high energy sources of varied types, from radar systems to radio systems, radio waves, radio frequencies, ultra high frequencies, other types of energies, subatomic or atomic energies. This is the world of nuclear chemistry when you talk about these things, and very few people go into nuclear chemistry. So, where do you start? How do we know these things have an impact on us? One of the hints is a microwave oven. If you go look for the resonant frequency of a water molecule, you'll find it's 1.2 gigahertz. Science, engineering, research, learning how things work has taught us about this. Not well, maybe, but it's taught us about this. So that little water molecule inside the food in your microwave begins to resonate with the energy from the microwave. But the energy from the microwave is transmitted at 2.4 gigahertz. If the technical specifications online are correct, that's twice the frequency of the resonance of that water molecule. Did it get complicated yet? Big things have to work. We have to have some ideas and understanding in how they work and encourage them to work. So where did that lead me to? Who studies resonant frequencies? And here's a hint article. This is from November 16th, 2007. This is past when I was involved with direct research in labs. By 25 years. But this is an article from the Max Planck Institute. Max Planck Gesellschaft. Now this is the land of MIT research or UCLA or whoever does these top research things. This is fundamental research on a molecular level this time, right? A molecule is a combination of different types of atoms, or the same type of atoms. In terms of physics, there is hardly any difference between the resonance in a molecule and a musical chord. Both are created when vibrations with different frequencies overlap. This is wave theory. My education in wave theory came from radar systems that still are applicable today. It's just we've gotten better at it. This is 50 years, 60, 70-year-old radar systems training. And the research, the intelligence, the common knowledge maintained by what we call science on radio waves. Radio waves are a lot like ocean waves. The similarities are uncanny, and there's many other types of waves that happen. So, this idea of chords and frequencies and molecules is a very real thing. In this case, 2007, Max Planck recognized it. There's other articles out there about frequencies and who does research on resonance of molecules. And therein lies some of the problems. Some people want to take this idea of resonance, this engineering idea of resonance, and turn it into mystical properties. When honestly, we don't have all the answers, but some people can explain it much better than I can. So this is about how these high energies interact, how they propagate, how we use them and can use them in order to learn more about the world around us, in order to have the internet that we have today, right? Because this is how big things work, the internet, where you can go almost anywhere on the planet and connect back to yourself, your virtual self on the internet. Amazing technical feat. Abused. Americans are getting pillaged and raped at the cost of our internet services compared to many other countries. Telephone services as well, but well, had to get something out. This idea of resonance, molecular resonance, and the impacts of it. And then you have to keep in mind it takes huge amounts of energy for these actions to begin to matter. You can't stick your head in a microwave. It's not a good idea. There's safeties in order to keep you from doing that. So please don't. And there's a reason for it, because that's how these waves, these things transfer into other parts of life around us. This interaction is how radiation therapy works. Some of the most complicated sciences on the planet. These interactions, this molecular interaction, is also how we have satellites that can see methane gases. Imagine seeing methane in the air. We have satellites specifically set up to do that don't get enough conversation. So, already too long. Peace is out. Be aware and take care.